Explain matrix multiplication. Now, when we multiply two matrices A and B, the product AB is only defined if the number of columns in the first matrix A is the same as the number of rows in the second matrix B. If that's not the case, we say that the matrix multiplication is undefined. Okay, so the matrix multiplication is defined by this equation here. So this is the element in row I, column J of the matrix multiplication A multiplied by B. So this element is equal to a sum of these two multiplied together. Now this looks quite complicated expressed in this way. It's easier if we think about it as the element in row I, column J of A times B, or A multiplied by B, is the sum of the elements across row I of A multiplied by the corresponding elements in column J of B. Okay, so I'll explain that using an example. Okay, so here we have two matrices, A and B, and we're going to calculate A multiplied by B. Okay, so the first thing we do is write out the matrices. Now this is useful for a number of reasons. Essentially I do this so that I have the two matrices next to each other. Now the first thing we check is whether the number of columns in our left matrix is the same as the number of rows in our right matrix. So a trick I like to do is just write out the dimensions of the matrices underneath. So the first number is the number of rows. So matrix A has 2 rows, and so rows are horizontal, and it has 2 columns. Columns are vertical, and we write this as 2 by 2. Okay, so if I do the same for both matrices, an easy way to check is whether the inside numbers are the same. And this here we've got 2, so we've got 2 columns in A, 2 rows in B, so this matrix multiplication is defined. The numbers on the outside, these give us the dimensions of the matrix we're going to end up with. So we're going to end up with a 2 by 2 matrix. Okay, so the element in row 1, column 1 of A times B, what we do is we go across row 1 of A, which is on the left, and down column 1 of B, which is on the right. And what we do is we multiply the corresponding elements. So the first element in row 1 of A is 1, and the first element in column 1 of B is 5. So we multiply these two together, and then we just go across the left matrix. So we're now if we go across row 1 of A, we've got a 2, and if we go down column 1 of B, we've got a 7. So we multiply 2 and 7 together, and we add them up. Okay, so that's row 1, column 1. If we move across to row 2, column 2, we do the same, but this time we're on column 2 of the right-hand matrix. Okay, so we've got 1 multiplied by 6 plus 2 multiplied by 8. If we go down to this element in row 2, column 1, so we go to row 2 of our left matrix, and we go back to column 1 of the right matrix. So now we have 3 multiplied by 5, 4 multiplied by 7. And finally, row 2, column 2, so we're in row 2 of the left matrix, column 2 of the right matrix, and we have 3 multiplied by 6 plus 4 multiplied by 8. So now we've got expressions for all 4 of our elements in A times B. So if we calculate what the multiplications are and then add them up, we can see that the matrix, this matrix here, this is the matrix multiplication of these two matrices A and B.